if I took my position on the number line, multiplied it by 2, subtracted 5, I would be 11 away from 0. So let's think about this. If my position is x, I multiply it by 2 and subtracted 5, I would be 11 away from 0. So I'm saying this position can be represented by 2x minus 5, which is also the same as 11, right? Because this is 11 away from 0. But there's another location that is 11 away from 0 over here at negative 11. So 2x minus 5 can also be represented there. So we're saying the distance away from 0 is 11. So I'm saying the distance away from 0 is 11. The absolute value of my expression has to be 11. So if I took 2x minus 5, which is the representation of my position, and I found the distance away from 0 that was, it would be 11. Well, I know that these distances at 11 away from 0 have to either be positionally at negative 11 or positive 11, which means twice my position minus 5 must be at negative 11, or twice my position minus 5 must be at positive 11. So here's the big difference, right? This first equation represents my distance from 0. Once I convert it to a positional equation, it has to be two different positions that I could be at. Okay, so big distinction here. Distance from 0 is represented by an absolute value, but the absolute value equation can be represented as two equations. One where the expression in the absolute value is positive, whatever the distance is away from 0, or negative, whatever the distance is from 0, because negative, the distance, gives you the position to the left, positive, the distance, gives you the position to the right. So let's solve these equations, or think about them at least. So what number can I take? I'm going to see what this thing has to represent. So what number does that have to be for me to be able to take 5 away from it to get negative 11? Negative 16 minus 5 is negative 11? No, that's minus 21. So what can I take 5 away from to get negative 11? Negative 6. If I'm 6 that way and I go 5 more that way to the left, I will end up at negative 11. So twice my position must be negative 6. So 2 times what gives me negative 6? Well, in this case, negative 3. Twice negative 3 gives me negative 6. Or, so I'm saying I'm at negative 3 is where my x is then. So that's one of my positions. Or, what could I take 5 away from to get 11? Well, this number right here must be 16, because 16 minus 5 is 11. So twice my position gives me 16, which means my position must be 8. So I'm at 8 is where x is. So I'm either here, where x is 8, or x is negative 3. And you can see that will work. If I took negative 3, doubled it, and then took 5 away from it, I would be at negative 11, which is 11 away from 0. Likewise, I could take 8, double it, take 5 away, and I would be at 11, which is also 11 away from 0. So the idea of absolute value of distance from 0 can help us find positions, can help us find values if we know how far away from 0 that expression or number or whatever we're given is from 0. And eventually we're going to start, finding unknowns. We might have unknown distances away from 0, and we'll have to solve for that.